Hi, welcome to the video lecture on measures of spread. We've already looked at measures of center of a distribution. The other thing we want to know about for the distribution for either a sample or a population is something about the spread. How spread out is it? Another term for spread is variability. We're going to look at two measures. We're going to look at the range and the standard deviation, and we're going to look at outliers as well. So let's start with the range because it's the easier one to calculate. It's just the maximum data point minus the minimum data point. So in our first example, we've got our largest data point is 100, the smallest data point is 20, the difference between them is 80. In our second example, the largest data point is 73, the smallest data point is 67. The difference between them is 6, so that's a range of 6. Now, I want to point out it's not incorrect to say that the data ranges from 67 to 73, but when they ask for the range, they're asking for the difference between them. So here the second data set has a smaller range, so in terms of the range, that data set is less spread out than the first data set. Okay, so let's look at the standard deviation. Standard deviation is by far the most widely used measure of spread. A way of thinking about the standard deviation is if you pick apart the term standard deviation, standard means typical, deviation means distance. It's a measure of the typical distance that the observations are away from the mean of the data set. If you think about it in terms of, if you think about it as the mean distance of all the observations from the middle, you'll be thinking about it in the right way. It's not quite that way, but that's close enough if you think about it that way. Okay, so just like for the mean, we've got a sample standard deviation and a population standard deviation. The sample standard deviation is lowercase s, and the population standard deviation is a lowercase Greek letter sigma. So s is our statistic, sigma is our parameter, and we're using s, which is s the statistic, to estimate sigma. So the sample standard deviation estimates the population standard deviation. So if you're keeping up with your list of symbols, s and sigma are big ones to go in there. Your textbook uses SD as a symbol for the standard deviation, and when they do that, they're usually referring to the population standard deviation. I'm not a fan of that notation, but your book uses it, so we'll go with it. Another thing I should tell you, with the mean, the sample mean and the population mean were calculated exactly the same way. With the standard deviation, there's a slight difference, and the difference is with the sample standard deviation, there's a minor adjustment for the fact that we're not talking about the sample of we're not talking about the standard deviation of the entire population. It's just a sample. So there's a small adjustment in the calculation to adjust for the fact that we're looking at a sample. So you need to know that the sample standard deviation is called the adjusted standard deviation, and the population standard deviation is called the unadjusted. That's because that's what you'll see in StatCrunch. So if I ask you for the population standard deviation in StatCrunch, you need the unadjusted one. The sample one would be the adjusted one. All right, so here's the formula for the population standard deviation, which can look a little intimidating for people, but basically we're just going to take every observation, subtract the mean from it, square the results, add all those up, divide by the sample size, and then take the square root. So let's do an example. So here's a data set, 67, 68, 70, 72, 73. And the mean comes out to be 70. So we need to do the numerator first of the fraction. So we're going to take every data point, subtract the mean of 70, and square the result. So 67 minus 70, square the result, gives you 9. You can follow along with all that. Next thing you do is you add all those up. So 9 plus 4 plus 0 plus 4 plus 9 gives you a total of 26. The next part of the calculation is divide by the sample size. The sample size is 5 in this data set. We had 5 observations. So you do that division and then take the square root. So you get a standard deviation, a population standard deviation of 2.2804. And I'll tell you the adjustment that takes place for the sample, the only difference is that in the denominator, instead of dividing by n, you're dividing by n minus 1. So it's a small adjustment, but it's one that matters. I'm only going to ask you to calculate this one by hand. Okay, so another terminology you'll see is this part in the numerator here is called the sum of the squared deviations. And this comes up later in the course when we do analysis of variance. It's called the sum of the squared deviations because every x minus the mean is the deviation. That's the distance. Square it, take the sum. So that's the sum of the squared deviations. So SS. That's a measure of variability. And you could that's a way of looking at variability that we don't really do, but it does come up when we get to analysis of variance, so I wanted to mention it now. The variance is another measure of spread. That's the mean of the sum of squared deviations, or it's the mean of the squared deviations. So the variance, another way of saying the variance is it's the standard deviation formula without taking the square root. So if you wanted to get the standard deviation, or if you wanted to get the variance, you could just take the standard deviation squared. So variance is good for statisticians because we use it relative to the normal distribution, but for us, it doesn't matter so much. For our example, the variance is just the number before we take the square root. Again, the sample standard deviation is the same formula as the population standard deviation. It's just we've got minus 1 in the denominator. And so the only thing different about the standard deviation that we did before is that it'd be 26 over 4 instead of 26 over 5. And so when we then take the square root. All right. Okay, so that's how to do the hand calculations. I want to tell you, in the textbook you see where they talk about a shortcut formula. I don't want you to use that formula. I want you to use the formula I just gave you because when I do the standard deviation the long way, the way I just showed you, to me it makes sense of what the standard deviation is really telling you. It lets you see that what you're doing is basically calculating the mean of the deviations. And besides that, the shortcut they give you isn't really shorter. So so when I say do it the long way, I want to see this way, and I won't give credit for the shortcut formula. So let's look at how to calculate the range and the standard deviation in StatCrunch. And actually, I have a different data set over here in StatCrunch, but that's all right. So our data set, this is wait times for a bank. So if we go to Stat, Summary Stats, Columns, I'm going to pick our variable, and now we want some statistics. Let's see. So we want the sample size, we want the standard deviation. That standard deviation is going to be the adjusted standard deviation. That's going to be the one for the sample. And let's also get the unadjusted standard deviation, and let's see the range as well. All right, so if we do that, and remember from before, if you want to add something on here, hold down the control button and then add, click what you want to see. So hold down the control button and hit min and max, for example. All right, so compute. So here, the sample standard deviation is 2.6164. The population standard deviation, if this is a population, would be 2.5050. The range is 9.49. Okay. Okay, so here's, this is just to recap all of it. If I were you, I'd probably pull this slide up and print it out just to have it handy. So the adjusted standard deviation is the one with the -1 in the denominator. Unadjusted is the population standard deviation, that's sigma. And use the second formula when I ask for it by hand. S squared or sigma squared is the variance, and the sum of squares is the sum of those squared deviations. Okay, let's talk about box plots. Box plots are used to help you see features of the distribution. So here's a box plot. We've talked about this a little bit before. This box tells you the middle 50% of the data is between about looks like about 5.5 and about 8.5. So the middle 50% of the data is in the box. This is the median. So the median here looks like it's about 6. This dot down here means there's an outlier. So that outlier is about 1. And then the bars, the whiskers they call them, go out to the highest and lowest observations other than the outliers. So I've got the data I can give you, but basically this is exactly what I said it was. The median is at about 6. The middle 50% is between 8.36 and 5.55 because that's the 25th and the 75th percentile. We have an outlier at 1, and then the remaining data has a maximum of 10.49 and a minimum of 3.82. So that's what we're looking for when we look at the box plots. The most important thing we look for, well, there's a couple things when we look at a box plot. One of them is the outliers. So that's a nice, easy way to look at outliers. And other than that, it kind of lets us get an idea for where the data is. So especially if you want to look at side-by-side box plots, it lets you compare two groups of data. All right. So here's the same box plot from SPSS. In SPSS, it'll give you a number next to any outliers. This does not mean that's the data value. This means that's the 12th observation in the data set. So that's the case number. Okay, so they think that you might want to go back and look at your data and see what was going on with that 12th observation that caused it to be an outlier, to see if there was something unusual there. So that's a good idea to further investigate that. That's what statisticians like to do. Let me show you how to get this in SPSS. I've got this data set here. Now I know you already know how to use the under graphs, legacy dialogues, we can get a box plot. But here's a way to get just about everything you want so far in the course all at one time. If we go to Analyze, Descriptive Statistics, Explore. So that's Analyze, Descriptive Statistics, Explore. Take the variable and move it over. Under plots, let's turn off the stem and leaf and turn on the histogram. All right, so that's under plots, and then we just click OK, and it gives us a lot of stuff all at one time. So all at one time, it gives us the mean, it gives us the median, the standard deviation. This is the sample standard deviation. The min, max, the range, some other things that we haven't talked about, and it gives us a histogram and a box plot. Okay, so that's a quick way to generate a lot of results, and that's the way I'd like you to get the mean most of the time. All right, so that's it for this lesson, and as always, let me know if you have any questions.